Hello. In the time we have left in the semester, I'd like to talk about three things: the wireless networks, and then mobile networks, which are not necessarily, wireless networks are not necessarily mobile, and if time permits, security. Now, the notes I'm about to show are based on slides at the Caros site for Chapter 7 of the 8th edition of the Caros-Ross book, which is the one I believe you have. We're talking about wireless networks. Most of you, and myself, we're connected to some. Elements of the network are the host, like our phones, the base station, which may be connected by wire to a wired network, and the base stations, which are also the relay stations that send the messages from the network nodes to the wireless network. Example would be a cell tower. Another kind of network we may talk about briefly later is a Bluetooth network. It's just one that suddenly comes into need when you, say, sync your phone with your computer. But it's not there permanently. So what should we say about wireless? Well, first of all, wireless has a lot of problems. The signal weakens as it passes through objects, even air, I think. And so it's not a long-distance carrier. The signal is interfered with by other transmissions and by motors. Lots of motors around. The signal bounces off objects, which means that copies of the signal, several copies of the signal, arrive at the receiver. They don't go straight, they bounce, and the different ones come there. Multiple senders can interfere with each other, and a sender may not take notice. For example, if A can't see C, but B can see both, then A and C transmit at the same time. B knows there was interference, but neither A and C does. Now, there's a bit error rate we can talk about, and a signal to noise rate. We want the signal to dominate the noise, of course. When we increase the power, we increase the signal to noise. But this leads to higher bit error rates. Now, several hosts can share a frequency by a method called Code Division Multiple Access, CDMA. This is getting back to the MAC layer we were talking about in the data link. Remember, there was a carrier detection media access. We were talking about the same kind of thing. In this method, the hosts can use the same frequency, but they each have a special sort of added pot that carries the code. That way, it's identified as theirs. The message that is sent is the XR, the XOR, that means the exclusive OR, of the chipping sequence and the data being sent. And for reasons that I don't quite understand, because I'm not interested in some of the electronics, the sources use -1 to represent 0 and 1 to represent 1. So let's look at some of this, how this is done. I'm supposing that we send a chipping sequence, and what I've done is I've just had 16 bits here. I would have written it 0001, 1100, 1011, and so on, but I switched the zeros to -1 here. And the data I want to send is another 16 bits. Now, how do I send the message? Well, if you remember the exclusive OR, the exclusive OR is 1 if either The first bit is 1, or the second bit is 1, but not both. So let's see. This is 0, 0, so that produces a 0. This is 0, 1, that produces a 1. So if you look down here, I hope I've taken each of these and tried to produce what is here. This is 0, 0, that's 0. This is 1, 1, that's still a 0. We can't have both. This is 1, 1, that's still a 0. 1, 0, that's a 1. 0, 1, that's a 1. 0, 1, and so on down the line. Now I've got some pictures of that from various sources. Here's one from What You Need to Know. Here's one from the Wikipedia that shows the signals as 0 and 1, up and down. Here's one from your text itself, which gives you an example of it. So you've got several ways to look at it. In the LAN world that we've been working in for a while, the local area networks, we have talked about over and over the 802 standard from the IEEE. Wi-Fi is 802.11, and there's many, many subcategories of it. But we'll just, for now, just talk about the 802.11 as a general idea. The wireless, the access point is the name they use for a base station. A cell, a basic service set, is either the AP and the devices connected to it, or a group of devices that directly connect to the internet, but make a network sort of an ad hoc fashion. The host must find an access point. So we got a Wi-Fi. You've seen this. You get on, and if you check, click it to on the bottom to look for Wi-Fi, you'll get a list of different Wi-Fis that are available. The host attempts to find an IP and get its name and its MAC address. The two possibilities, it does dynamic host configuration protocol, of course called DHCP. Two possibilities. Passive scanning. The access point sends out messages. The host, when it gets one of these messages, sends hi to one of the APs. And the AP acts it. And therefore, they're connected. Active scanning is the host sends out a request saying, I need an AP. And one or more of the APs respond to that address. And then the host picks one and says, hi, I want to associate with you. And the AP says, fine, I will associate with you. 802.11 is CSMA, Carrier Sense Media Access. That is what we did with the Aloha network. But there's one thing missing. We don't have collision detection. Excuse me. Instead of collision detection, we have something called collision avoidance, CA. The idea of collision avoidance is shown in this diagram here. The station wants to send. It senses the channel. That's the carrier sense part, the CS. If the channel's busy, it'll wait, and then it'll make a new attempt. And it'll keep going. Now, if pardon me, that was channel visit. Channel free, it will transmit the data. But unfortunately, somebody else has been doing the same thing. So there's a collision detected. It transmits a jam signal, backs off somehow, and then tries again. And it keeps going and going like that. So it's not entirely collision detection. It doesn't send it out and say, I hear a collision. It hopes that it'll send it out and not hear a collision. But if it does, then it has to react to it. So it tries to avoid it. Now there's pictures here of how it does this. And this is a picture from your text, I believe. It shows the various signals that go back and forth. It's got a CTS, response to send, and clear to send signals. And then there's this how long shall we wait routine. And there are so many different possibilities here. There are sifs, piffs, diffs, ifs, and afs. Try saying that real fast. And they're all basically different periods of time for different cases. I copied this from one of the sites. If you really need to, you can look at it. Maybe we'll need to, but I don't know at this point. But they're all there. We don't have to get into the technical details at the moment. Now, like everything else, there's a standard for what goes into a frame. This picture is a very nice picture. It shows sort of the whole thing. There's the MAC header. Then there's what comes from above, and a little trailer. And the what comes from above includes the upper layers and all that kind of stuff. But then the frame contains a frame control, 4 addresses actually, and other stuff. And some of this is explained in the slides. It explains these particular addresses, a MAC address of the router interface, a MAC address of the wireless AP or host, that's sending, that's transmitting, that's receiving, of the router. And this goes into a little more detail of different ideas that what go into different kinds of frames. There's a whole flock of different frame types. I've given you a source here. The site that I got this from contains that. Now, I don't think that I can use my computer to get an 802.11 Wireshark output. However, I went on the web, and several places have exercises that involve these, and they have various Wireshark captures. So what I'm going to do is send you one of these Wireshark captures and try to decide by looking at the different sites what kind of things I might want to ask you about it. I expect you'll also receive a small little homework that might talk a little about the chipping sequence and possibly some other things if I can think of some. So somewhere within the next day or two, you're going to receive a video on wireless, and then probably the last video or videos will be on security. So that's where we are at the moment. We'll see you later now. Bye.